All right, so on Friday, and if you weren't up this morning, we practiced solving some systems of equations. Those were your straight up Algebra 1 review type problems. We had at our disposal 3 ways. We did which 3 ways to solve? Substitution, elimination, and graphing. When is it good for graphing? When they're both in the y equals form, right? When it says y equals, hey, we can go straight to our calculator, punch it in, press graph, boom, there's my answer, right? When's it good for substitution? When something's already by itself, I just, hey, plug that bad boy in, let's go. Elimination is basically when they're stacked on top of each other and my x's and my y's are lined up. Hey, let's just eliminate and move on down the line, right? Now, we were also putting together the concept that the answer is the intersection, correct? All right, so we're going to Algebra 2 that concept up just a little bit here for a second. Now, here I've given you a system of equations. How many solutions does this system have? 4. Well, I'm hearing 2 different answers.
It's definitely 4.
Definitely 4. Well, by definition, what is a solution? Where the 2 intersect, right?
Dude, no, that was Keaton. I'm not that.
You okay with that?
Yeah.
Let's look at another one.
They don't.
How about that?
One solution.
It was 1. What does that mean? That means it only intersects in one place. This is your big Algebra 2 word. It is tangent. When you hear the phrase tangent, that means, hey, it touches it only one time. Make sense there? I got one more example. So someone said, hey, no solution. Why? They don't touch, right? So these are basically your 3 options. So when I have a linear and a quadratic, how many solutions am I allowed to have? 2 or 0. So I got 2, 1, or 0. Is it possible for me to be infinitely many solutions? I'm hearing no, but not a lot of confident no's.
Maybe.
Maybe. Well, what does it mean if they are infinitely many solutions? They're like right on top of each other, right? They mirror everywhere I go, you get the same answer. Is it possible with a straight line and a curved line to be infinitely many solutions? Absolutely not. So now we got some confidence there. So what do you think? Kind of understand where we're going, yes? Let's look at this first example. Y equals 3x, or y plus 3x equals 0, and y minus 6 equals negative 3x squared. Now, your primary way of doing these problems is going to be substitution. Elimination is kind of out the window because you can't really do elimination with a linear or nonlinear because not enough stuff will eliminate for me to get to where I need to go. Does that make sense? So what I'm going to have to do is I'm going to have to do substitution. I have trained you to pick on the little guy. Which one of these is the little guy? See the one on the top, right? It's not squared. That's always automatically a good thing, right? So let's take that y plus 3x equals 0 and let's isolate which variable? The y. So it's going to be y equals negative 3x. Now, the next step in substitution is where I actually substitute, correct? Where do I substitute? In for y. What do I do from there?
You can add 3x.
I can add 3x, I could, but I'm gonna do you one better. I'm gonna add 3x squared. The reason I did it that way, Andre, is because I'm setting this up. So at least two people have the big bright eyes because they just clicked with what we're doing. I'm creating a quadratic equation, right? But I'm gonna try to make this as easy as possible for myself. When I see this problem, what do I notice? It equals 0. Okay, that's one good thing, but what can I do to make it easier? I can divide everything there by 3. So 3 divided by 3 is negative 3x divided by 3 is, and negative 6 divided by 3 is, and 0 divided by 3 is 0. Which made my numbers easier to manage. Now, this is one of the cool parts about Algebra 2. Everything that we learn, we keep learning and we keep using. Like, remember when we spent all that time factoring quadratics? I said, hey, you better learn this because it's important stuff. Here we are. Remember we said, hey, we can factor it. We can complete the square. We did the AC formula. We did the quadratic formula. You pick it, we did it. I do not care which one you do. I want you to use what you're best at. But I am going to highly recommend using the quadratic formula because it works every time. Does that make sense? So let's do the quadratic formula just to get our practice in. I'll write it up there so that way some of you can remember. So negative b plus or minus the square root. B squared, -1 times -1 is 1. Minus 4 times A times C all over 2 times A. 2 times 1 is 2, so I saved myself a step. What comes next? We'll simplify what's under the root. So -4 times 1 is -4. -4 times -2 is +8. So 1 plus 8 is
3, so it's 1 plus or minus 3.
1 plus or minus 3 over 2. 1 plus 3 is
4 over 2.
4 over 2 is 2. 1 minus 3 is
2.
-2. What's -1?
Didn't you have the negative over 1?
No, because it was minus a negative.
What do you mean?
Negative b. It's already negative.
Oh.
Minus negative squared got positive. So am I done? I have to plug them back in, right? Well, what do those represent? No. See how I'm working along in my problem?
Yeah.
What are those? So what are these? So x equals 2 and x equals -1. See way up here at the top where I've got this thing right here? Let's plug in those x's to get their y's. So how do I write my answer? And because I have 2 answers, correct? Yes. Because what are my options? 2, 1, or 0. All right, for another example. What about this one? Oh my goodness. Oh. It's not that bad. I have a linear and a quadratic, yes? So I have trained you. Go after the little one. So that's the bottom one. Which variable do I want to get by itself? So we're going to get x by itself. So in that bottom equation, what do I have to do to get x by itself? So x equals y plus 6. So that's what I'm going to plug in to this equation. What do you think there? Okay. What do I do next? Oh, I don't want to do that yet. Let's start on the inside of the most set of principles, right? So I have y plus 6 minus 3. What's y plus 6 minus 3? Good job, Mr. Casey. Some of you knew that, you just afraid you were wrong. So now, what do I do next? Well, order of operations tell me to do what? So I got to take care of the exponent before I distribute. Yes. So what next? Y plus 3 squared. What does y plus 3 squared actually mean?
Y plus 3 times y plus 3.
Oh, I love it. What does that mean I do? I FOIL. Find my like terms in the middle, correct? Y plus 1 equals 1/2 y squared 6y plus 9. Now I distribute. But I don't want to do that. Because if I distribute, that's going to make 3 fractions. And I don't want to do that. So what I'm going to do is I'm going to multiply it by its reciprocal to make that go away. Ah, now we're cooking, right? That's a whole lot better than having fractions. So we should multiply everything over here by 2 as well. So 2 times y, 2 times 1. What do I have to do next? So I got to get it equal to 0, correct? Because I want to move everything over so that it's equal to 0 because quadratics have to equal 0 before I can solve, correct? So minus 2y minus 2. Six y minus 2y is 4y. 9 minus 2 is
7.
what do I do from there?
You did a quadratic formula.
Now I'm ready to do my quadratic formula. Negative b plus or minus the square root. B squared minus 4 a times c all over 2 times a. How do I simplify that part? So negative 4 times 1 times 7 is negative 28. 16 minus 28 is negative, I don't know. All right, good job. Now, what does that mean?
Yeah, pull I out.
I have to pull an eye out. Okay, I'm glad you said that. So what does that mean if it's imaginary?
There is no solution.
It means it's not real, so it has no real solution.
So you can just.
So I can just stop there because it has no real solution. Like that. Why do I know it has no real solution? Because it's imaginary. Remember a couple weeks ago when we were looking at the discriminant? When it's positive, I have how many solutions? 2 real solutions. When it's negative, I have 2 imaginary solutions. But when it's 0, I have 1. See, we're still using that. See, I don't teach you guys things just to teach you things. So we're going to use everything. So what are you thinking? It is a lot of work, but it's not hard. Is that a fair statement? It's not hard work, it's just they're long. There's a lot of room to make mistakes. Your last example. Don't freak out. Amy throws a quarter from the top of a building at the same time that a balloon is released from the ground. The equation describing the height y above the ground of the quarter in feet is y equals 64 minus 2x squared, where x is the time in seconds. The equation describing the elevation of the balloon in feet is y equals 6x plus 8, where x is the time in seconds. After how many seconds will the balloon and the quarter pass each other? Check your solution for reasonableness. I'm going to do this 2 ways. One of them just to show you that it can happen, and the other just because that's the way I want you to do it. Keaton, I noticed you picked up your calculator. What have you noticed? You're going to type it in. Why do you know you're just going to type it in?
Because you can grab it.
Both of my equations are already y equals. Because they're both already y equals, that means I can go straight to my calculator and push graph.
You said that X is
Something like that. It'll work either way. 64 minus 2x squared and 6x plus 8. So I'm going to give you a quick sketch of what I see.
I see a parabola.
I see a parabola with a line going through it and it kind of cuts there. That's exactly what mine looks like. Now, I can mess with my zoom window to get there, but based off of this graph, what can I state? Do they intersect?
No.
They don't?
Yeah.
You don't think if I kept going on forever, eventually they cross each other?
Yeah.
So what's that going to tell me? There is at least 1 or 2 solutions, right?
Yeah.
This is definitely not a no solution because they're going to intersect. If I zoom out, you'll see them, but you get so far zoomed out, it's really hard to estimate based off your picture. So what I'm going to do is I'm going to algebraically solve. Oh man, but it's okay because they're both already y equals, right? So because they're both already y equals, substituting one into the other is basically just setting them equal to each other. Now I'm going to get everything on one side, right? negative 2x squared minus 6x minus 8. What's 64 minus 8? Well, you know, I'm all about making my job easy as I go, right? What can I do to help myself here? Divide everything by 2. I'm on one up it. Divided by negative 2, because that's going to make less negatives, right? So negative 2x squared divided by negative 2 is negative 6x divided by negative 2 is 56 divided by negative 2 is negative 28. Now remember, if you're really good at factoring, there's nothing stopping you from factoring right here. You understand that, correct?
Yeah.
But because I know imaginary numbers are a thing and I need to look out for them, I'm going to try to use the quadratic formula every time because it's never wrong. You understand that, right? So negative b plus or minus the square root of b squared, 3 times 3 is 9, minus 4 times 1 is still negative 4, negative 28, all over 2 times 8. 9 minus 4 times negative 28, 121. What's the square root of 121? So what are my two answers? Negative 3 plus 11 is 8. 8 divided by 2 is 4. Negative 3 minus 11 is negative 14 divided by 2 is negative 7. So now I plug those back in to get the values that correspond. Sure, I could. 6 times 4 is 24. 24 plus 8 is 6 times negative 7 is negative 42. Negative 42 plus 8 is. These are my two solutions. Remember that last statement. Make sure your answer, check your answer for reasonableness, right? Which of these two is not a reasonable answer? Why? Because there's no negative height, there's no negative time. What is the answer to the question? Remember, they asked me specifically, after how many seconds? No. 4 seconds. And at what height? We'll go with B because it sounds good. What do you think? Word problem's not as scary as you thought it would be. I think it's actually easier than some of the other ones that we did. All right, your homework is on my.hrw.com. There are only 12. At least 3 or 4 of them, I only ask you to tell me the number of solutions. Questions? Comments? All right.